It's a pleasure to be here with you today to talk about edge rendering with Nuxt, which is something that's very dear to my heart after spending some time with it over the last few weeks and months. Just to introduce myself, I'm Daniel Rowe. You probably wouldn't guess it from my Twitter handle. My background is that I've done a lot of work with real applications. So after founding a digital agency, I then moved on to work with a HR tech SaaS startup. And so I've been using Nuxt for quite a while, building real applications and encountering problems and finding solutions. And that's really the perspective that I bring when I talk about edge rendering. I'm part of the Nuxt framework team, so that means I get to see all the cool new features that we're building and work on some of them as well. I imagine that's perhaps one of the most fun parts of my job at the moment. I maintain a couple of libraries like Versal Builder and the Nuxt Composition API, so you might have come across me that way. But today, I want to talk a little bit about edge rendering with Nuxt, and to understand why this is the right direction for us to move in. It's worth asking why use Nuxt in the first place. And for me, I would point to two main things, really. The fact that it's a progressive framework, so you can pick up Nuxt with no configuration, no background in Nuxt at all, and it works. It's almost like magic. You just drop a pages directory on your computer and you start adding Vue components to it, and that's magically served up for you. There's still something amazing about seeing the look in people's eyes for the first time when they realize it is as simple as that. It's meant to have the best practices built in. So things like good Webpack configuration, or the best SEO practice, or other features that you might not know to start with, but which Nuxt just takes care of without you having to think about it. But at the same time, and this is always really important to me, Nuxt allows you to take full control. So you can configure everything. There's almost nothing that Nuxt does that you can't override or do in a different way if you want to, which means that it's a progressive framework. It meets you wherever you are. It progresses with you. It allows you to extend it where you want to extend it and not where you don't. And Nuxt is multi-target. I think that's one of the main things that people notice when they come to it for the first time. It doesn't just run in the browser. It also runs in the Node environment. And we often use the word isomorphic when we're talking about rendering in different contexts. And in fact, more recently, Nuxt actually produces different browser targets. Like many projects, we're able to detect, based on module, no module loading, something about the capabilities of the browser and transpile the code differently. So we actually have 3 targets at the moment that we support with Nuxt. And the idea is that you can write code once, and it runs in all of these targets, and that allows some of the cool features like isomorphic rendering, rendering something on the server that is then hydrated on the client side. Lots of things are changing, though. So there's the rise of serverless architecture. So more and more, rather than a node server running in the background serving requests, we actually have Lambdas that are fired up per request. There are Jamstack innovations, such as trying to move more and more to static pages, which are really unsurpassed in terms of performance because they can be cached at CDN level, while hydrating them and making them dynamic with API requests and other kinds of data input. There are new targets coming out, so it's not just Node and browser anymore. Dino is on the scene as a potential rival to Node. There are worker targets. So Cloudflare Workers, for example, has a completely different environment using V8 isolates. And of course, ES modules are replacing common JS, and TypeScript is cool and new and prevents lots of bugs and errors. And more, I think we're seeing a move towards talking about data, not HTML. not just the fully rendered page, but actually all the data that makes up the page, and figuring out how best to create interactive experiences that depend on that data, rather than just pre-generating, say, a page of HTML. But lots of things haven't changed. And in particular, I would say that the need for server rendering content is more important than ever. So from my perspective, the user experience is most important. So the fact that you get something in your browser from moment one that actually displays something for you. And the idea of progressive enhancement as well. So it's there, it works, and hopefully it works even before the hydration process completes. Certainly you're able to read and get content, but you should also be able to follow links and interact with the page in some ways. It means you have this great combination of dynamism and speed. And of course, I would be remiss not to mention the search engine benefits from having fully rendered HTML. Now, Nitro is the next step for Nuxt. So we actually developed Nitro as part of building Nuxt 3. And already some of the innovations that we are building into Nuxt 3 are coming back to retrofit at Nuxt 2. And that's no exception with Nitro. So Nitro was built with Nuxt 3 in mind, and a lot of its tech is that's what inspires it. But it is actually designed, like so much of what we're doing at the moment, to be backported and those innovations to be brought into applications that still run on Nuxt 2. So what is Nitro? Nitro is a second stage build. So if you were to compile your normal Nuxt project, and you were to look in your .nuxt directory, you would see a client and a server build. And at the moment in Nuxt 2, for example, that server build isn't independent. You can't just take it anywhere and run it. You actually have to have Nuxt or Nuxt Start installed, and then that enables you to fire it up. With Nitro, we take that server build and we process it. We build it a second time with Rollup. Rather than Webpack. And we bundle split it, and we optimize it, and we analyze it. And we do lots of cool things, which I'll explain in just a moment. But we were able basically to build another thing, another server on the back of the first output. And this second server becomes what you run with Nitro. It's cross-platform, which means it can run in far more than just your node environment, and that enables lots of really interesting features as well. So let me go into more detail. So Nitro is built for cold start performance from the beginning. So if you're just running a normal server, you want to load everything up front. So you want to load all your code into memory, because memory is by far the fastest way of responding to requests. But if in fact you're building for Lambda, that's not what you want at all. You want it to start as fast as possible, and then only the parts of code that need to be loaded into memory in order to respond to a request. And then if the Lambda gets reused for another request, that's fine. It can reuse them or load in more chunks. So to start with, Nitro produces a server bundle, a server that's bundle split. And then chunks are loaded in async fashion. This is also really crucial when using something like Cloudflare, for example, because Cloudflare has file size limits. And if we want to take advantage of some of the features that it offers, we actually need to fetch chunks from the key value store in order to load them. So we bundle split. So what your request first hits is a request handler powered by a new server called H3, which looks much like any other node server, except that it's not node dependent. It has exactly the same API as, say, something you might be familiar with in terms of Connect or Express. But it can run in the browser. It can run in Cloudflare workers. It can run on Dino. And this server only has one job, which is to identify what chunks need to be loaded to respond to that particular request. And those chunks can load more chunks and so on. So this orchestrator will first decide whether it needs to serve a static file. Some of our targets, like your normal node server, will actually be serving the static files as well. That won't always be true. If you're serving with something like Azure Static Web Apps or something like Vercel, then actually the static files will be served by a different service. It will never hit the Lambda at all. But then there are also lots of other features. So different APIs that you might call at different endpoints. And the same is true with any different page that you access in your Nuxt site. Those are all separately bundle split into different routes. So if you hit a request for page 1, it doesn't load the bundle that's needed to serve page 2. And then alongside this, we have this $fetch, which is an isomorphic fetch for accessing your own APIs and external ones. So it has an interface very similar to your normal browser fetch or node fetch. Again, custom-built cross-platform tool called OhmyFetch, which you can investigate. But this means within your server-side rendering, you can actually call an API, and if it's being rendered on the server, it will just load the necessary bundle to actually respond to that call without needing to hit it or create a new request. Now, on the client side, it will create a new request and hit the proper endpoint. So it's almost magical. It's an isomorphic access to data. You just have to define your API and your Vue page in the same instance, and Nitro handles it for you perfectly. And then all of this data, so all the APIs, all the dependencies for the Nuxt server, we actually trace them using a great innovation from Vercel called NFT node file trace. And we identify all the files that are needed in order to run the server. And in fact, this is an option. All of these things are options, but we're able to then just pull what's required to be bundled up so that you only have one directory and it can be dropped anywhere. You don't need to bring anything else, and definitely not anything that is superfluous to the job. And then, of course, because the objective is to make this as fast to start as possible, we pre-run any expensive operations. So we support e-tags and identifying whether whether content is changed in a request, but we do all of that in advance, even to the point of identifying MIME types in advance, so that the static file server doesn't have to include massive MIME library. It only actually needs to store the metadata on the particular static files that are present at generate time. And the result, here's an example of a real-world application. This is the Nuxt Hacker News app. The server timings we generate based on each chunk as it's loaded. And this is a sample request to the basic news feed. You can see that the cold start is 20 milliseconds. And the total time to generate the whole thing is somewhere between 50 and 80 milliseconds. That's everything. That's even server-side requests, and that's all the pages being rendered and all the chunks and data being loaded. It's really exciting to see the performance improvement you can get with something like Nitro. It's cross-environment by design, and this actually does fit in with the cold start performance. So we're launching with support for lots of platforms out of the box, some of which are zero configuration. So you simply have to deploy your projects to Vercel or Netlify or Azure Static Web Apps, and it just works. Nitro detects where it's running. It builds the right kind of file and puts it in the right kind of location for those platforms to auto detect and launch a fully dynamic app. But in order to run in all these different environments, particularly Cloudflare, which is not node-based, is that your normal Nuxt app probably depends on quite a lot of dependencies that are node-specific. And so Nitro will auto-mock dependencies, particularly ones that aren't needed. So dependencies that aren't needed get replaced by very clever magical import, which won't throw any errors, but it won't do anything either. So, for example, if you're dependent on a particular console logging package or a debugging package that has reference to node dependencies. It won't do anything. That will also tremendously speed up the app in terms of starting it. For particular packages that are needed, we've built a whole suite of ultra lightweight polyfills using the nuxt.un library. Check it out. It's growing, and it basically enables a lot of what Nitro does. And all of this means that we're able to push rendering closer and closer to the edge. So it can run in Cloudflare workers with their 0 millisecond cold start. That's pretty cool. In fact, just as a proof of concept, we've even got Vue Nuxt rendering working in browser service workers, meaning you can have one server effectively running in the browser, serving multiple tabs and producing fully rendered HTML. Not suitable for production use right yet, but still pretty cool. And because we want to make this for the next generation web, it's not just about creating a server. It's also about creating something that is hybrid, where only what's needed can be updated. So you can generate as many static pages as you like. They'll be served directly from the CDN of whatever service you use. You can, if you're using the Nuxt full static with Nuxt 2, we have experimental support for payload-only dynamic API. So as you're navigating from one page to the other, rather than regenerate the entire page, we can actually serve, rather than have to perform lots and lots of API requests on the client side, we can actually serve up the data that's required just from the server. That's all that's needed to render the page on the client side. And we can, in fact, edge render the pages that we don't actually have pre-generated, all of which means that we're able to do some pretty cool things with caching. And that's definitely a space to watch as we announce some of the new features we have coming with Nitro. So what about using Nitro now? And I guess the key thing to say is that using Nitro now is really only for those who aren't faint-hearted. It's really cool, it's really fast, but it's definitely going to break. You'll have opportunity to see things fail. And it also raises the question, of course, about what it's like to build for Nitro and what it's like to build for Nuxt 3. So alongside the rapid development on Nitro itself, we're going to be releasing a new package called Nuxt Kit, which is primarily for module authors, but means that packages, modules that are being developed can actually be used either in a Nuxt 2 or a Nuxt 3 environment, because we don't want it to be this big cliff edge as we step into Nuxt 3. It's going to be more like a progressive enhancement. If you're able to use Nitro with Nuxt 2 and some of the other cool things we have coming, it actually means it shouldn't be such a big ask when you convert things across to Nuxt 3. So here's how you might, for example, deploy a Nuxt 2 application to Nuxt 3, to Nitro. I've picked the Nuxt Hacker News application as an example of a real-world application. So we have our basic Nuxt 2 app. I could even fire up a Visual Studio Code workspace, and you can see everything there. The first thing that we're going to need to do is install our package, Nitro. We'll add that to the dev dependencies. And while it installs, we're going to need to add a module to the build modules of this app. So we're going to add Nuxt Nitro compat. Nitro itself is built for Nuxt 3, but this module enables that to be used with Nuxt 2. And with that in place, that's pretty much all we absolutely need to do. I'll make one more change. So I'll add the .output folder to our git ignore. That's where Nitro sticks everything that it produces. and we don't want to commit that to version control. But let's build our app. So running nuxt build now, because everything is integrated with the module, will not only build our Nuxt app, but it will also build our Nitro app. So you see it's generated this folder alongside our .nuxt folder, a .output folder. And in there we have public. This is where you would see all the things that you would stick on a CDN. So all of our client-side Nuxt bundles, our service worker, our favicon, all those kinds of things. And then in the server folder, this is your Nitro built server. So we have a simple entry point. This is that tiny H3 orchestrator that figures out what it needs to serve. And then it serves up the bundle split app. So we have a static file server there. We also have a number of different pages, and each of those pages has its own bundle that Nitro is able to load as needed. Just to give you an idea of the kind of speed that Nitro is capable of, here is a project I built earlier. So starting Nitro takes on the order of 50 milliseconds. That's your cold start. And then to actually perform a request to Nitro, it's virtually as fast as you can type. So I can simply perform, and this is fully server-side rendered. Each page is completely dynamic. You can see something of the performance there. So that first request, and this is in debugging mode to enable the injection of timings. On that first request, it takes 2 milliseconds to load up the static file server. It takes 0.005 milliseconds to add a header to add some timing data. It takes 50 milliseconds to actually render the page, and that includes rendering a dynamically bundle split module with lots and lots of different quotes for us. The whole thing is incredibly fast. In fact, it's difficult to measure it because the thing that takes the most time is actually just the overhead of whatever tool you're using to measure it. But Nitro is insanely fast and insanely fun. If you're interested in taking part in experimenting with Nuxt 2 and Nitro, if you'd like to be kept up to date with everything that's happening and some of the cool new things that we have planned, please just drop me a line. I'll keep you updated. I'll let you know what's coming. But one thing is for sure, Nitro is going to make this coming year really quite exciting if you're using Nuxt. Thanks very much. Feel free to get in touch with any questions. I'd be happy to answer.